All right, today we are going to break down one of the most powerful and honestly, one of the most intuitive algorithms in all of machine learning, the decision tree. It's so cool because it basically mimics the way our own brains work. The logic, it's surprisingly straightforward. So let's just dive right in.
Just think about it for a second. How do you actually make a decision? You probably ask a series of questions, right? One question kind of leads to the next, and then another, until you finally land on an answer. Well, if you can do that, congratulations. You're already thinking just like a decision tree.
And that brings us to our first big idea here. At its core, a decision tree isn't some kind of mysterious, complicated black box. Nope. It's really just a flowchart for making choices, something we've all seen and probably used before. Okay, let's make this super simple. Imagine you're trying to decide, should I play outside? Your first question is probably, is it raining? If the answer is yes, well, you're staying inside. But if it's no, you ask another question. Is it hot out? If it's hot, maybe you go for a swim. If it's not, you go play football. See what we did there? It's just a series of simple questions or splits that lead to a really clear final decision. And that is the absolute key takeaway. A decision tree is just a machine learning model that takes that exact process we just went through and automates it. It learns these rules from data by asking a sequence of questions, all to make one final prediction.
Okay, so we've got the basic concept down. Now let's get a little more formal and actually break down the anatomy of a tree, because it has a very specific structure that's really important to understand.
Every single tree starts at what's called the root node. Now, this isn't just some random question. It's the single most powerful first question the algorithm can possibly ask. It's the one that does the best job of separating the data right from the get-go. So after that first big question at the root, we get to the decision nodes. You can just think of these as all the follow-up questions. Each one takes a chunk of data and splits it again and again, getting more and more specific as we go further down the branches of the tree. And where do all these paths finally end? Well, they end at the leaf nodes. These are the final answers, the end of the line. No more questions here. This is where the tree gives you its prediction, like loan approved or spam email.
And here you can see the whole flow perfectly. See? You start right at the top with the root node, you follow the branches based on the answers to the questions, you pass through a few decision nodes, and bam, you land at a leaf node which gives you the final prediction. It's a totally transparent journey from question to answer. But, okay, how does the tree actually know which questions to ask, and in what order? This is where the real magic happens. This is what we call the art of splitting. The goal is actually super simple. At every single step, the tree just wants to ask the one question that will split the data in the cleanest way possible, creating the most pure groups it can.
And this visualizes that goal perfectly. Look on the left. A good split creates these groups that are way more pure. They're mostly one category. But on the right, that bad split just leaves everything all mixed up. And that doesn't really help us get any closer to a clear decision, does it?
So how does it actually measure this purity with math? Well, it uses concepts with fancy names like Gini Impurity or information gain. But hey, don't get bogged down by the formulas. Just think of it like this. They both measure how mixed up a group of data is. The algorithm's entire goal is to find the one question that causes the biggest drop in that mixed upness, creating the purest, cleanest groups it can.
Okay, so decision trees seem pretty great, right? They're simple, they make sense, but they have one major fatal flaw if you're not careful. And we have to talk about it. It's the problem of overfitting.
This quote really says it all. A decision tree, if you just let it run wild, won't just learn the general patterns. No, it will keep growing and splitting and growing until it has perfectly memorized every single data point it's ever seen, including all the noise and all the random little quirks.
I mean, just look at the difference here. On the left, you've got a simple, smaller tree. It learns the main important rules. This one is way more likely to work well on new data it's never seen before. But on the right, that huge, complex tree has created a special rule for every tiny little exception. It's like a student who memorized the textbook but can't apply any of it in the real world.
And that's really the bottom line here. Overfitting gives you a model that looks absolutely fantastic on the data it trained on, maybe even getting 100% accuracy. But the second you show it some new, unseen real-world data, its performance just collapses. Why? Because it memorized all the noise instead of learning the actual underlying principles. So, the big question is, how do we stop this from happening? Well, we have to control the tree's growth. We can set limits right from the start, like telling it, hey, don't grow past this certain depth. Or we can use a really cool technique called pruning, where we literally go back and snip off the branches that are too specific and don't really add much predictive power.
Now, even with this risk of overfitting, decision trees are still incredibly important in machine learning. So let's wrap this up by looking at why they matter so much.
Okay, their biggest advantage, hands down, is that they are super easy to understand. You can literally trace the path from the root to a leaf and explain exactly why a decision was made. They think like we do. Now, the downside, as we've talked about, is that they can overfit like crazy. And they can also be pretty unstable, meaning even tiny changes in your data can sometimes lead to a completely different tree.
But here's the real kicker, the reason they are so essential. They are the fundamental building blocks for some of the most powerful algorithms we use today. Seriously, models like random forests, which is literally an army of decision trees all voting together, and gradient boosting, they are all built on this simple foundation. If you understand a single tree, you're on your way to understanding these giants of machine learning.
And believe me, these models are everywhere. They are making decisions that affect our daily lives all the time. From deciding if your credit card application gets approved, to helping doctors diagnose diseases, to figuring out which customers might be about to cancel their subscription, the simple logic of the decision tree is humming away in the background.
So I'll just leave you with this one final thought. The next time you're facing a really complex problem, try breaking it down. Just break it down into a series of simple yes or no questions. You might just find that what you're looking at is a decision tree waiting to be solved. Thanks for joining me.